Hi, and welcome to day 6 of Trig Graphs. Alright, I know I have a lot written down. Actually, it's all written down, but I tried the video once and it didn't save properly for me, so I'm not rewriting it all. Some things I have up on the screen. You can see I've drawn the sine graph, the cosine graph, and the tangent graph. And I have my two special right triangles. We're going to be using that information in order to help us with the problems here. So if you need to pause the video, copy that information down. Today we're talking about arc relations. I know it kind of looks funny because I have it in lowercase letters for arc relations, but there is a reason why it's in lowercase a, and tomorrow we'll learn that in the next video why it's lowercase. But and when it's lowercase, it means something different than when it's uppercase. So we have theta is equal to the arc sine y if and only if, that's what the double arrows mean, y equals sine theta. And theta equals arc cosine y if and only if y equals cosine theta. And theta equals arc tan y if and only if y equals tan theta. The arc stuff is like when you use your calculator and you do the second sine, second cosine, or second tangent. Sometimes we use the graphs depending on the values, or the triangles, or the calculator will always work. But I use the graphs when y is equal to plus or minus 1 or 0. And when I have a radical, a fraction, a decimal, I would use the special right triangles or my calculator, depending on what kind of fractions I have and decimals I have. This back over here now. The directions, we are to rewrite the statement as an equivalent statement using sine theta, cosine theta, or tan theta. And then B, find all the values between 0 and 360 inclusive. So let's try this. For number 1, I have theta equals arc cosine of 1. I'm going to rewrite it to 1 equals cosine theta. The 1 is in place of y. And cosine theta is equal to 1 at 0 and 360 when you look at the graph. You can see that. For number 2, the arc tan of 0 is equal to theta. So 0 is equal to the tangent of theta. And again, I look at my tangent curve, and I look to see where my graph is 0, where it crosses the x-axis. It crosses at 0, 180, and 360 degrees. For number 3, I have the arc cosine of a negative radical 3 over 2 is equal to theta. So when I rewrite that, I have negative radical 3 over 2 equals cosine theta. I have to find a reference angle here, because if I don't find a reference angle, I can't answer all my questions. It's a negative radical 3 over 2. Cosine is negative in quadrants 2 and 3, so I have to find the angles that are in quadrants 2 and 3. So in quadrant 2, I would do 180 minus theta, excuse me. In quadrant 3, I would do 180 plus theta, and in quadrant 4, I would do 360 minus theta. So I have theta equals, for quadrant 2, 180 minus 30, because my reference angle is 30, because cosine is equal to radical 3 over 2 when theta is 30. And I get 150 degrees for quadrant 2. And then in quadrant 3, I have theta equals 180 plus 30, which gives me 210 degrees. So I actually have two answers here for this one. For number 4, I have theta equals the arctan of radical 3. So radical 3 equals the tan of theta. Looking back on our triangles, the reference angle is 60 degrees. So tangent is positive in quadrants 1 and 3. So in quadrant 1, the reference angle is my answer. So theta is equal to 60. And in quadrant 3, I would do 180 plus 60, so I get 240 degrees. For number 5, we have the arc sine of negative 0.6 equals theta. So negative 0.6 equals sine theta. And On this, I have to use my calculator because we don't have anything special for 0.6. And I'm going to put in sine inverse, so second sine of 0.6, not a negative 0.6. I need you to do it positive so that I can get my reference angle. Otherwise, I only get one of my angles, and I won't have my reference angles, and I won't be able to find the other angle. So sine is negative in quadrants 3 and 4. So in quadrant 3, I do 180 plus 37, which is 217. And in quadrant 4, I do 360 minus 37, which is 323. All right, for the last three problems, they're a little bit different because they have two trig functions in the problems. So I have cosine of the arcsine of negative 2/3. So I'm going to deal with inside my parentheses first and rewrite it as negative 2/3 equals the sine of theta. So on my calculator, I'll do second sine of negative 2/3. This time, when it's used to two trig functions, you can actually use your negative, and you'll get a negative 42 degrees, just round to the nearest degree, and then you hit the cosine of negative 42 degrees, and you get 0.7431. For number 7, we have the cotan of the arctan of 8/5. So we have to do second tan of 8 divided by 3, and we get 58 degrees. And we're going to find the cotangent of 58 degrees. Well, there's no cotangent button on the calculator, so we do 1 divided by the tangent of 58 degrees, and we would get 0.6249. And we're going to talk about that one in class because there's something special about that problem I want to show you in class. And then for number 8, we have the sine of the arctan is 0. When you're doing two trig functions, just go ahead and use your calculator because tangent has 3 places when it's equal to 0. So tangent's equal to 0 at 0. Sine of 0 is 0. I hope that wasn't too fast for you. I'm sorry about that, but I had a little technical difficulties tonight, so I wanted to make sure I cleared that up. All right, that's it.